Welcome, everyone. Today we are pleased to announce M2.5. And what we call M2.5 is the Fendermint release. And what does this mean for IPC? So first of all, we welcome Fendermint to the IPC stack. If some of you are early adopters of IPC, you probably know that we were using Lotus as the base peer implementation for IPC, which meant that subnets run Lotus-based blockchains in order to handle their operation. What happened with Lotus? Lotus had several issues, not because of Lotus, but because of us. And one of the reasons is that we wanted a composable peer implementation that allowed different consensus, abstractions, generalizations. And Lotus was built for Filecoin, and it didn't have these abstractions in place. So when we tried to put these abstractions in place, we realized that we broke everything. And we had a really brittle peer implementation. So that's how we said, OK, let's have an experiment of what would it mean to rewrite the peer implementation for the subnet. So we took an off-the-shelf consensus like Comet BFT, the Fendermint core, and we rewrote all of our stack using Comet BFT and an FVM IPLD-based application on top of it. And this would be our subnet implementation. And so, yeah, we rewrote it in Rust. I mean, again. And the idea and the reason why we did it is because we wanted to see to what extent we could have a composable blockchain implementation or peer implementation for subnets. So that's why we got an off-the-shelf BFT consensus where we could embed, because one of the problems we had with Lotus is that it was really hard to embed many of the IPC mechanics into the peer because it's really Filecoin tailored, it wasn't that general. So we said, let's see to what extent we can have an IPC enabled implementation. So that's why we said, let's forget about consensus. We're going to worry about consensus afterwards. Let's pick a consensus that has a clear abstraction. So that's why we wanted to use Comet BFT with the ABCI interface. And let's see to what extent we can start generalizing our peer implementation. And that's how we ended up with this Fendermint experiment that is becoming our go-to production peer implementation for subnets. Then there was another issue, the fact that we were using Lotus and we couldn't embed all of this logic into the Lotus client meant that we had to over-engineer many of the IPC communications. Everyone has been talking about this communication between subnets, checkpointing, bottom-up, top-down messages, all of these primitives. They were really hard before because the fact that we couldn't embed a lot of these into the peer implementation and make it abstract them made it really hard to work with them and actually implement them. So our contracts had a full refactor. Our contracts now, I mean, I don't know if you've been following IPC, but it was briefly mentioned before they were WASM actors. Now they are Solidity contracts, which means that you can deploy anywhere. Deploying Filecoin, please. We really want to target Filecoin as the first network, but I mean, on your own risk, you could even deploy over Ethereum. And the three main things that we have improved in the actors and refactor is, first of all, the parent finality. So before, it was kind of hard because one of the processes that we have is that the subnet is listening to what is happening to events in the parent, right? And that's how we know that there has been additions to the collateral, the power table, top-down messages, events that may be from the outside even. So syscalls, asynchronous syscalls, which are not there, but Raul introduced briefly. So all of that is based on this parent finality primitive. And before it was super over-engineered, we have simplified it a lot. The second thing that we have improved is the bottom-up checkpoint. So before, every validator had to submit a checkpoint and vote for a checkpoint directly in the parent. And this was really inefficient in terms of gas, in terms of complexity. And now we've simplified this in a way where the validators of the subnet, they're only worried about signing in their subnet. So they're worried about what is happening in their network. And then there's a network of relayers that are operating and are listening to these checkpoints and submitting it for a reward in the parent. So they have their own alternative network. We'll see in a moment how this works. And finally, we have really improved collateral management. One of the early feedbacks that we got from developers is that the collateral was too straightforward, and it meant that we didn't have delays when validator left. We didn't have many of the mechanics that you see in other frameworks. Ours was really simple. And here what we've done is actually implemented. And some of the ideas that they're not there yet implemented, but that we will have is, for instance, delegated collateral and all of the other things that you may have seen already in other ecosystems. So this is what we've done is another abstraction over collateral. So this is all abstractions, right? We've implemented the pipes so that in the future we are able to actually put additional, allow subnets to tailor to their needs and add additional functionality over these pipes. So really briefly, how does this parent finality work? So we have our parent chain. It can be Falcon. It can be, we may be a layer 3. It may be some other layer 2. We have all of these validators, which is our validator set from the subnet. And then we have our child ledger and child consensus. So periodically, what validators do is that they don't only vote, so they don't only agree on what is the transactions and like the new state that happens in the subnet, but they also listen to the parent, and as part of the block proposal, they also propose what is the finality that they see from the parent. So for instance, here, validator 1 is the leader in the case of Comet BFT, but this could apply to any other consensus. Whatever the block proposer is, it would say, hey, this is the height and the CID that I see in the parent. And as part of the consensus, they need to actually agree on, to accept the block on the finality that they see. So that the parent finality, it's committed in the child. And this is really interesting, because what we're doing is actually interleaving the history from the parent into the history of the child, allowing us to trigger side effects. So whenever, imagine that there was a top-down message that was initialized was triggered in height 100, the validators in the child know that once they reach the finality committed on-chain from the parent at height 100, they can execute all of the side effects from there on, until that point, which means that every top-down messages, every change for collateral, we can make them effective in the child. So this is the main refactor that we've suffered. I don't know if you recall, all of the OG from IPC may recall how complex was before. This process now is way simpler. And then we have the bottom-up checkpoints. This is the pipes that allows us to move information from the child to the parent. And in this case, what happens is that periodically we have a checkpoint period, right? You can think of the checkpoint period as this clock of the system. So for instance, n blocks, and this is a checkpoint, n being the checkpoint period, the validators will populate the checkpoint for certain height and sign it. And sign it and commit it to the ledger. So they will sign, adding information about the state of the child, some CID root, some CK proof in the future, all of the messages that we want to propagate, additional information that we want to give feedback of to the parent. So they all sign this transaction. And when they reach a quorum, what happens is that the child ledger will emit a quorum event. And relayers will be fighting to listen to this quorum event and racing to submit the checkpoint into the parent. In this way, we are giving incentives to this relayer network to be able to commit to the parent. There's a lot of incentive mechanisms for the relayer. There may be questions we can discuss afterwards because, okay, I still have 20 minutes, but just in case. Cool. That's more of the low level technical things that were happening. But we also another of the early feedbacks and complaints about IPC from our users is it's really hard to use. So, and we get it. There are a lot of modular pieces, a lot of moving pieces that is hard to make work together. So we started a line of work in order to improve the UX. And one of the things that, again, if you used IPC in the past and you're starting to use M2.5, something that you may realize is that there's no IPC agent anymore. So this inconvenient process that you had to run in order to interact with IPC, we've removed it. And now what we have is a Rust library and an IPC CLI that allow you to orchestrate the communication with the different subnets directly without having to have a dedicated process. And also, farewell to our beloved Lotus, which we are deprecating support. For some time, we were supporting both, Fendermint and Lotus. We've decided that we're going to deprecate Lotus, at least for now. We're still supporting Lotus in the parent. You can, as you'll see in a moment, we're anchoring our subnets right now to Falcon, which means that we still support Lotus to some extent, but we are not supporting Fendermint-based subnets based on Lotus. So some of the highlights that you may see in M2.5 regarding UX. First of all, the IPC provider. We have this Rust library that you can embed into your applications and that allows you to interact with subnets. We have the IPC CLI that removes the need of running the daemon. And then we have and I say coming soon because they're there, but like we need to stabilize a few features and merge a few PRs, but we are working on a TypeScript provider so that from your node-based backends, from your front-ends based on Next or like any JS framework, you can interact directly. Like if you were from the IPC CLI or the IPC provider, you will be able to interact with subnets. And with this enables another few tools that we're working on, which is the subnet visualizer. So a way of seeing, instead of using the IPC CLI, seeing what is happening in a subnet, and the quick start wizard that I may glimpse a bit today, where we built a really simple interface in order to deploy subnets, so that it abstracts of many of the tools and many of the inconveniences of having to interact with a terminal or use any other of these libraries. So for the less nerdy and hacky people, this is what potentially you will be using. And thank you to the VM team, the VMDX team, because they helped us with a new docs site. Another of the huge complaints from the early users. How the hell I start using IPC? The documentation is in a repo. I want to see like proper tutorials. I want to see like how IPC works. So we're horrible with docs and design in the IPC team, at least the engineering team. So we had to ask for help from the VMDX team, and we now have a really cool doc site that, it should be your entry point for IPC. And I don't know, like raise your hand if you remember SpaceNet. Okay. There are people, all from the IPC team, but I don't care. There are hands. So SpaceNet was our previous Lotus-based native factor testnet. And this is what all of the feedback that we got from users, it came from their test applications over this testnet that was the first IPC testnet. And I'm proud to announce that now we have a new testnet, but this time it's not a layer 1 or a root network where you can deploy IPC. Now what we have is a layer 2 in calibration called Mycelium. And this is going to be what eventually will be anchored to Falcon mainnet. So this is all the tests that we're doing of having a general purpose IPC layer 2 for Falcon. This is the testnet. So this is the Mycelium calibration, but you can expect in the future a Mycelium in testnet. So what is this Mycelium? The idea behind Mycelium is to have a layer 2 IPC that can be used off the shelf without you having to worry about finding validators for your subnet, deploying your subnet, and all of these complexities. And it's a general purpose L2 that is anchored to calibration. The fact that it's running, so this is something that, a question that we get when we've moved, because if you recall from Lotus, in Lotus we had this Trantor consensus that had like 1 second block times. Now we have Comet PFT, but like, actually, the DX team, I think that they did a demo yesterday, and they were like, oh, this is fast. Because one of the things why we have Mycelium in calibration is because we are able to have less than 3 second block times. And also it has low fees compared to calibration, it's faster, fast finality compared to calibration, and it allows you to do cross-net execution. So the goal of this Mycelium calibration is to start testing all of these deployment of subnets, fast finality, and all of these things that high-level things that the previous talk were introducing. So to offer a general purpose L2 that applications can start using from the beginning without having to deploy their own subnet. So the TLDR is that you have a faster calibration that is a layer 2 and it's IPC powered. So you will have all of these top-down, bottom-up cross-net primitives. Disclaimer. We love disclaimers. So disclaimer, this is a work in progress. So, I mean, we've been testing it, we're improving it every week. Like here in LabWeek, we were more like improving the stack than actually enjoying all of these talks and all of the good food. So if you see issues like the same, I mean, for those that were around in SpaceNet, the IPC team is really friendly. They answer to Slack, they are lovely. So whenever you see a bug, whenever you see some blogger and so on, just feel free to drop a message and help us improve it. Like actually, this M2.5 is just a reply to all of the concerns and feedback that we had from the SpaceNet days. Another huge announcement, and George, thank you for this and many others that fought against BlockScout and Fendermint. So Fendermint is compatible with Ethereum block explorers. And if you go to this, I mean, probably you can scan that QR. I haven't even tested it. But like if you go to this URL, you will see the Mycelium Calibration Explorer, where you can see what is happening in the network and in the Mycelium L2, as if it was any other Falcon or EVM-based network. And of course, like, we have a faucet, because you will need some tokens in order to interact with Mycelium and with this layer 2. So we have this faucet where you can directly get funds for your address in Mycelium. And you may be thinking, but what if calibration, like this faucet is down or it runs out of funds? It doesn't matter, because remember that Mycelium is a layer 2 of calibration. So you can always, and we're in APC world, so we have cross-net messages, and you can always get some funds from calibration, do this fancy dandy command, and send those funds to Mycelium. So even if for some reason the Mycelium faucet fails, remember that you are an L2 of calibration, so you can always like take your funds down from calibration. Cool, and many of you may be asking, if this is your first IPC technical talk or like this release note talk, you may be thinking like, okay, but what can I do today with IPC? Because everyone is talking about these high-level fancy features. What can we do today? Okay, so the few things that you can do today seamlessly, and I say seamlessly because you could always do more complex stuff, tinkering with the code. But like for those of you that don't like to tinker with the code, and I say this because we're missing some of the abstractions. So the features are there, but the abstractions to users are not the most user-friendly. So if today you say, hey, I want to try IPC, these are the things that you can do. You can deploy Fendermint subnets. So have your own sidechain that does these cross-net interactions, commits checkpoints, and so on from any IPC-enabled network, either calibration, Mycelium, or your own network. Because as everyone has been mentioning before, this protocol is recursive. Then you can deploy EVM contracts. And not only EVM contracts, the fact that you have your own network allows you, with just a few tweaks, to deploy your own system contracts. So your own native WASM contracts within the subnet. So actually, I'm going to give you a quick spoiler. The IPC actors are EVM actors that are deployed in Genesis when you deploy your contracts. So the same thing that we do with the IPC actors is the same feature that you could use yourself. So you could either deploy native WASM actors or your own Solidity contracts in Genesis to provide them to your users immediately. And we have basic crossnet transactions. And this is something that we really want feedback about, because like now they are really in a really rough state in terms of like we don't know what people want to do with this. So as much as you can break this, it would be great to get your feedback. Cool. And this is the steps to deploy a subnet. And you may see here a lot of commands. It's like quite complex, but fortunately, the team has been working also in the IPC trampoline, which is a getting started wizard that allows you, instead of having to write down all of these commands in your terminal, it will allow you to deploy a subnet from a user interface, which is really convenient. And we have a demo. This is not yet. We don't have a release for this. This is in an early stage. So you may need to wait 1 or 2 weeks for this. But like I wanted to give you a primer. Oh no, request access. So now you won't believe me that this exists. There was a cool video that was showing how we deployed a subnet from the front end, but it doesn't matter. I can show you on my phone at some point. No worries. Yeah, but like, let me probably walk you through here. Like basically, we had these steps that are the ones that we were used to, like create a subnet that deploys the subnet actor, join the subnet from the different validators in order to bootstrap the subnet, and then deploying all of the infrastructure. And the idea of this wizard is that, especially, this is supposed to be used locally. If you want your really production ready environment, you may deploy it yourself for your infrastructure. But like the idea is that if you're testing locally or you're testing networks, that you're able to do all of those steps that you see in the terminal by using MetaMask and your browser. So you will select the parent network from which you want to anchor, initially Mycelium calibration and the actual calibration, generate the validator identities, create the subnet by deploying the subnet actor, and finally, joining the subnet. And from there on, we would be able to trigger and deploy the infrastructure. So this is the kind of things like that were surfaced from the feedback from users. So please use it. I cannot stress it enough. Use it as much as you can and give us feedback, because this is the kind of tools that the team will end up focusing on from your early feedback. Cool. And to give you a more short-term view, because like all of the previous talks have been focusing on the high level of like what we can achieve with IPC, but what can you expect in the next few months for IPC? And with few months, I mean like 2-3 months. First of all, upgrades. Like till now, every time that we upgrade the IPC protocol, it was kind of a pain, because we had to update users with the new addresses of the subnet, especially for the rootnet. We have already the implementation. We haven't merged it and we haven't released it, but we have an implementation of upgradable contracts. So now every contract in IPC will be upgradable, and we will be able to seamlessly upgrade because we implemented that diamond architecture on the Solidity contracts. So updating and improving like increasing the functionality of subnets in case you want to customize the reference implementation of subnet actors is way easier. We are going to introduce slashing. Marco briefly mentioned it. One of the things, we have collateral, we have validators in subnets with skin in the game, but we don't have a way of penalizing them if they misbehave. So we are working on like identifying a set of misbehaviors that can be easily proved to the parent, so that their collateral as slash and their power in the power table is reduced. Then something that I think also Raul mentioned is that we want, or it was Parth, but like we want to have to abstract and generalize even the gas model. So we want to be able to allow EIP 1559 or like first auction in subnets easily. And this is another thing that we're working on, like figuring out all of the gas model abstractions and fees to allow subnets to have their own gas model. And then there is a lot of work that we're doing. You saw the wizard, my mention to the subnet visualizer. There's a lot of work that we're doing around like how to improve the UX and improve the visibility of subnets. Bear in mind that this was a research project until quite recently, and now we are trying to move it into production. So all of the tech is there, all of the stack is there, but like we need to like use the wrapper that makes it amenable for actual users. So yeah, a huge round of applause to the team. They have been hard at work, but unfortunately, it's not time to nap. We still need to work harder and get this into the users. So usually, by the end of this talk, usually what I do is like I go through some of the frequently asked questions that I get after these talks, or like after presenting IPC and so on. But maybe as you didn't have the chance to ask questions, we can do a round of questions.